North Atlantic off the coast of Newfoundland, the point where it all ended. 269 meters long, 53 meters tall, 46,329 tons. These numbers tell one story and one story alone. This was the largest moving structure ever built by human hands. At the dawn of the 20th century, 269 meters is roughly the length of 3 football pitches laid end to end. 53 meters is the height of a modern 17-story building. 46,329 tons was heavier than any vessel that had ever sailed before it. Inside this enormous hull, 16 watertight bulkheads had been installed. A watertight bulkhead is a reinforced wall that divides the hull into separate sealed compartments, designed to prevent water from spreading from one section to another in the event of a breach. The engineering specifications guaranteed that even if 4 compartments flooded simultaneously, the ship would maintain enough buoyancy to stay afloat. Based on this design, the press coined a single phrase: the ship that even God could not sink. That was not exaggeration. It was absolute confidence in the engineering of the age. On its maiden voyage, 2,200 passengers and crew stepped aboard. From first class to third class, from wealthy industrialists to immigrants chasing a new life on a new continent, every one of them boarded on the promise that this ship could never go down. As it pulled away from the harbor, crowds cheered, the horn bellowed across the water, and not a single soul imagined that this ship would never return. Now, 113 years later, 3,800 meters below the surface of the Atlantic, that ship is being seen again. This is not a salvage operation. It is a life-size digital twin, reconstructed from 715,000 underwater photographs. And buried within that data is the truth about the sinking that has never been told until now. North Atlantic off the coast of Newfoundland, the point where it all ended. The first truth the 3D scan data revealed was the duration of the collision itself. The iceberg made contact with the hull for exactly 6.3 seconds. 6.3 seconds. That is roughly the time it takes to draw one deep breath and let it out. In that fleeting moment, the fate of a 46,329-ton ship was sealed. For decades, the accepted explanation went like this: a massive iceberg scraped along the side of the hull, tearing a continuous gash roughly 90 meters long. This account appeared in textbooks and documentaries and was repeated without question for over a century. But the digital twin analysis told a completely different story. The damage on the outer hull plates was not a single continuous tear. Instead, it appeared as a series of small, intermittent openings, spread across 6 separate sections of the hull. The size of each individual opening was startlingly small. Each gap was no larger than a single sheet of A4 paper. A4 paper, the same size as an ordinary document held in one hand. When the total area of all these small fractures was added together, it amounted to roughly 1.1 square meters, on a hull stretching 269 meters from bow to stern. That is an almost invisible amount of damage, and yet these tiny gaps brought down a 46,329-ton ship. How could a handful of holes the size of a sheet of paper drag the largest passenger liner in history beneath the ocean? The 3D data reconstructs that process second by second, and what it reveals is that the problem was never the size of the holes. It was where the holes were located. North Atlantic off the coast of Newfoundland, the point where it all ended. 16 watertight bulkheads. These were the foundation of the myth that this ship could never be sunk. The principle behind them was straightforward. Divide the hull into 16 independent compartments. Place a watertight wall between each one, and prevent water in any single compartment from spilling over into the next. Thanks to this design, even if 4 compartments flooded at the same time, the remaining 12 would provide enough buoyancy to keep the entire vessel above water. In theory, it was a flawless system, but the 3D scan data identified one critical defect hidden within that design: the height of the bulkheads. The walls did not extend all the way to the top of the hull. They stopped at E-deck level, and above that point, the space was completely open. The tops of the bulkheads never reached the ceiling. Think of it like an ice cube tray with dividers that are too short. Fill one compartment with water, and the moment the water level rises above the divider, it simply spills over into the next compartment. The iceberg impact damaged 5 compartments at the bow. The design could withstand 4. When the 5th compartment breached, the limit had been exceeded. As the bow sank under the weight of the flooding water, the water level inside the damaged compartments rose above the top of the bulkheads. Gravity did the rest. Water poured over the top of the wall and into the sixth compartment. One compartment fell, then the next, then the next. A cascading chain reaction of flooding had begun, exactly like a row of falling dominoes. What sank the unsinkable ship was not the iceberg. It was the design itself. The decision not to extend the bulkheads all the way to the ceiling. North Atlantic, off the coast of Newfoundland, the point where it all ended. When the ship began to tilt, most people moved upward. Toward the deck, toward the lifeboats, toward anywhere that was higher than where they stood. But there were those who went in the opposite direction. 35 engineers. They voluntarily returned to the boiler rooms that were already taking on water. They knew that climbing up meant a chance to survive. They went down instead. The reason was singular. Electrical power. Consider what happens when the power fails. First, the wireless telegraph goes silent. The SOS distress signal can no longer be transmitted. Next, every light on every deck goes dark. 2,200 passengers and crew are plunged into total darkness in the middle of the Atlantic at night. Then the bilge pumps stop. The last mechanism slowing the rate of flooding ceases to function entirely. The moment the power dies, the odds of survival drop to near zero. The 35 engineers understood this. The 3D scan data preserves unmistakable traces from inside those boiler rooms. The position where coal shovels were left standing. The angle of steam valves still locked in the open position. The condition of generators that show evidence of operation until the very last moments. These data points confirm a single fact. All 35 engineers remained in the boiler rooms. None of them came back up. According to the historical record, the lights on the upper decks did not go out until just moments before the ship disappeared beneath the surface. That was not coincidence. The last light that 700 survivors saw from the lifeboats was the result of a choice that 35 men paid for with their lives. North Atlantic, off the coast of Newfoundland, the point where it all ended. 2 hours and 40 minutes. That is how long it took for a 46,329-ton ship to vanish completely beneath the surface. 2 hours and 40 minutes is roughly the length of a single film. During that span of time, the lives of 2,200 people hung in the balance on that deck. The 3D scan data reconstructed this process stage by stage. Stage 1. As the forward compartments flooded, the bow began its slow descent beneath the waterline. Thousands of tons of seawater poured into the forward sections, dragging the bow deeper and deeper below the surface. Stage 2. As the bow sank, the stern rose. The principle is the same as a seesaw. One end goes down, the other end comes up. As the stern lifted, the massive propellers and rudder broke through the surface and hung exposed against the night sky. Stage 3. Once the angle of tilt exceeded a critical threshold, the stress concentrated at the midpoint of the hull, surpassed the structural limits of the steel. The full weight of 46,329 tons focused on a single point, and the hull could no longer hold. The ship broke in two. The bow section plunged toward the ocean floor first. It took approximately 6 minutes to reach the bottom at 3,800 meters, striking the seabed at an estimated speed of 40 kilometers per hour. The stern briefly righted itself after separating, then tilted vertical once more and followed the bow down. On the ocean floor today, the bow and the stern rest approximately 600 meters apart. Surrounding them, across an area of 60 square kilometers, tens of thousands of fragments of debris lie scattered. North Atlantic, off the coast of Newfoundland, the point where it all ended. 715,000 underwater photographs, 16 terabytes of data, a life-size digital twin. The true value of this project lies far beyond preservation of a historical record. Once the digital twin was completed, theories that had been accepted as fact for over a century began to unravel one by one. The first to fall was the mechanics of the collision itself. The long-held claim that the iceberg tore through the hull turned out to be wrong. Analysis of the 3D data revealed that the force of impact caused the rivets, holding the hull plates together to fail. As the rivets popped free, the steel plates separated at the seams, and gaps opened between them. The hull was not torn. It was pulled apart. That distinction is not merely a matter of wording. It fundamentally changes where the structural weakness lay. Metallurgical analysis of the rivets recovered from the site revealed a composition highly susceptible to brittleness in low-temperature conditions. The near-freezing water temperature of the North Atlantic degraded the structural integrity of the rivets, and upon impact they fractured in sequence, rather than absorbing the force. This discovery did not stop at reinterpreting the past. Modern cruise ship watertight bulkhead design standards are now being reevaluated on the basis of this data. Bulkhead height specifications, rivet material criteria, structural stress testing protocols for cold water environments. All are under review. Data from a disaster 113 years ago is now reshaping the safety standards of the present. A tragedy of the past has become the blueprint for future survival. That is the real change the digital twin has brought. North Atlantic, off the coast of Newfoundland, the point where it all ended. 3,800 meters below the surface. In this darkness where no sunlight reaches, the ship is disappearing even now. A species of bacteria called Halomonas titanicae inhabits the site. This organism feeds on iron. It survives by breaking down the steel structures of the hull, an extremophile thriving in conditions lethal to almost all other life. Each year, hundreds of kilograms of the hull are consumed by this bacterium and crumble into sediment. Marine scientists have warned that within a matter of decades, the hull may deteriorate beyond recognition. A structure that once stretched 269 meters across the ocean could vanish without a trace. That is precisely why this digital twin project carries a significance far greater than documentation. When the physical wreck is gone, the data will remain. 715,000 photographs, 16 terabytes of three-dimensional coordinate data. Every surface of the hull recorded to the millimeter. This is the most precise underwater record that humanity has ever created. 113 years ago, a ship that was believed to be unsinkable went down. 1,500 people disappeared into the freezing water. 700 watched those final moments from the lifeboats. And now, as the wreck itself slowly vanishes, a project is underway to preserve it as data for eternity. When that record is complete, we will finally understand in full what happened on that night. And the last story of the 1,500 who rest at 3,800 meters will at last be told to its end.